Jared Dunning. We're here to prove relative motion using a tennis ball, a slingshot, this tape measure, and that automobile.
And what are you doing for the video?
I wanted to be the slingshotter. But that didn't work out. So ours are shorter.
Okay.
So I was just a video camera person. And I was like the model in my peacock boots.
Okay.
And I'm Caitlin.
And okay, what?
I'm Jared Dunning. I was the guy that shot the tennis ball out the window, and the entire reason this experiment was successful.
I'm Linda. I was the driver of the getaway car. AKA the experimentation vehicle. And I got to go in reverse and drive, in reverse and drive, in reverse and drive about 20 times.
And pick up tennis balls.
And pick up tennis balls.
So according to relative motion, you should not be able to release this ball going at a certain speed, while a slower speed than what this speed is going, and from this moving object. And we would have to actually, in fact, release it upon seeing this window if we hope to get it in here, because the object is in motion.
So my hypothesis was that you cannot wait until the target is right in front of you for you to release the object, in this case tennis ball, and that so we're proposing that you have to release it before the target gets in front of you, and yeah.
Whose law is that?
In the target, which in our
Front
case,
window going to be rolled up or down?
The front window is rolled up
For the
because
safety.
I did not want to get knocked out.
You would have been knocked out by now.
I would have.
Because we hit the window.
Like, I would have crashed into the school.
It would've been
This
bad.
would have been no more.
I can pull like a wild card. Oh.
Caitlin, if you make me sterile, I'll never forgive you.
Oh, that's on tape.
Way too close.
That is on tape.
How you gonna solve that? Science is cool. Yeah.
Good. And you pull back.
That's false. That's false.
Come on, Caitlin.
Okay, so Linda's gonna speed up,
yeah,
and
good.
as soon as
She's coming.
as soon as she hits the pole, she's gonna reach 20 miles an hour.
I don't. That's not important. It just goes.
Okay, so Jared, explain what we're doing here. Why are we standing? We stand on this line, don't we? Every single time.
Yes, we do stand on this line because we need consistency
Consistency.
in our experimentation.
Es importante.
When her window passes.
Yep.
Oh, my finger's cramping. Oh, God. God. This is it. This is the moment of triumph.
Caitlin, how did this work?
Okay, so according to the hypothesis that Jared already stated, we're trying to shoot a ball into the window of a car. So to eliminate as many variables as we could, Linda started before a certain point, and when she hit this certain point, this said point, she was trying to reach a speed of 20 miles an hour, and she stayed on a straight line up for, it was 80 feet. And the person stood at said 80 feet, and then when the window of the car was directly in front of that person, they shot the ball. And so that was our first video of the fact that when you shoot the ball at the window, it's not going to go in because the car's already going to be passed. Then the second time we tried it, we shot at the front of the car. So when we measured that, it was 72 feet. So the person is going to shoot the ball, launch the ball, when Linda has traveled 72 feet from the light pole up towards the person. That also didn't work. It didn't get as far as it was supposed to go. And then our final video was when Jarrett shot the ball at the front window at Linda's head. And
So much love in this group.
that was
Yes. So it was when the car had traveled
another
77 feet.
77 feet. So the car traveled from the light pole to 77 feet. We could have made the dimensions a little smaller, but we were too late.
What were the dimensions of the window?
The dimensions of the window were 27 inches by 10 inches. So that was the distance that we had. And we had a basket in there. We weren't necessarily trying to get it in the basket. That was just something to keep Linda safe so that the ball wasn't bouncing around everywhere.
Which I appreciate.
Yeah. And we tried this experiment like
8 times.
No, it was like 18 times.
18
What's your
times.
opinion of science?
My opinion.
Alright,
of
so Caitlin, did we experience any problems during this?
Yeah, our problems. First of all, I tried to shoot and I'm retarded at it, so Jarrett took over. He's got it. And then, let's see here. We also had an issue of like the space between the person shooting the slingshot and the car. The slingshot wasn't able to, well, excuse me, the person was not able to like shoot it far enough to get in the car. And then, shoot, I think that's about it other than the fact that it's hot.
Do it! No, keep doing it!
That's what she was. She was like a little bit like, Thriller!
Oh my goodness.
Yeah, okay, well anyway.
That's what she was doing. It needs to be a little bit more like that. I'm like a little bit more like that.
This is the impersonation of Jarrett by Caitlin. You can. Do it.
Oh,
Just try it. Just try it. Please.
I get really self-conscious.
Like 10 seconds ago, you were like, alright, we're gonna get the ball in the car. Is it any harder
No,
than that?
we're gonna get the damn ball in the car. Is it any harder than that?
The target gets in front of you. And yeah.
Whose law is that?
In the target, which in our case the target is the window.
Of
My car,
said
the
car.
badass car of the world.
In this. The spirit's gonna push me through the bottle.
It's like a victory meal.
It is a victory.
Until Tavner says that project sucked. You guys took a sort of lunch.
Impression of Dr. Tapper. You have too many variables.
I'm putting that in the video.
Yeah. Should we do it against the background, like a pretty background over here? Like, do it like against the.
What's your opinion of science?
It's my opinion of science. No comment.
Science is cool, guys. Science is cool.